Okay, so this was kind of like the first thing we did. And this is the shifting of a line. And I'm not going to have you go on the graph. It's a little bit harder to see it on the graph. These lines are going to infinity in both directions. Essentially, what we're trying to do is get the shift off of the function here as well as the point here. The parentheses represents our horizontal shift, whether we're going right or left. What makes this parenthesis equal to 0 is 2. So if it's a positive number that makes the parenthesis equal to 0, we're going to the right. So in this case, the shift is right 2. The number out here represents my vertical shift. Since it's a negative, we keep the sign out here. That shift is down 3. So if I shift this point 2, 6, right 2 and down 3, right 2 from an x coordinate of 2 is 4. Down 3 from a y coordinate of 6 is 3. And that's all I'm asking for you on the test, is to give me that new point. You don't need to graph it. You don't need to give explanation or theory on it. If you take a look at the second one, okay, here's my starting point, 3, negative 13. It's got to make this true right here. It does. Now, what makes this parenthesis equal to 0? It's a negative 7. So if I'm going negative, that means left according to the x-axis. The number out here with its sign represents the vertical shift. So I'm going up 6. If I go left 7 from 3 on the x-axis, that brings me to negative 4. If I'm going up 6 from negative 13 up the y-axis, it would be negative 7. So that's my new point, negative 4, negative 7. My vertex. What makes the absolute value equal to 0? 3. What makes, or not what makes, what's this number here with this sign? Negative 1. That's going to be my vertex every single time, whether it's an absolute value graph or a quadratic graph. Okay, that's the vertex. Since the A is positive, we're not reflecting over the x-axis. There's no reflection over the x-axis. The shift is your vertex. Where'd your vertex go from 0, 0? It went right 3, down 1. And it has a vertical stretch stretch by a factor of 2. And obviously that A being bigger than 1, we can circle the vertical stretch for that option as well. Okay, so the vertex, the reflection, if A is positive, there's no reflection. If the A is negative, it's yes to a reflection over the x-axis. The shift is always the vertex. Where's the vertex going from 0, 0? Right 3, down 1. If the A is bigger than 1 or less than negative 1, we have vertical stretch. If the A is less than 1 or bigger than greater than 1, so it's a fraction with a lot of times a 1 coefficient, doesn't have to be, but a lot of times it is, then we have vertical shrink. Okay? The shift, right 3, down 1, and we write about the vertical stretch or shrink. In this case, vertical stretch by a factor of 2. And then we can circle the vertical stretch. When we go to graph it, my advice, put the vertex in the middle. 3, negative 1. I'm counting down. I'm counting up. If you can't do it in your head, that's okay. My y equals 2. Absolute value of 4 minus 3 minus 1. Absolute value of 1. The absolute value of 1 is 1. And 2 times 1 is 2. 2 minus 1. We get 1. So a 4 is 1. 2 is 1. Let's try 5. Y equals 2 times the absolute value of 5 minus 3 minus 1. The absolute value of 2 is 2. And then we get 4 minus 1, which means it's 3. Actually, I can put my y's here as well. And now I'm plotting the points. An absolute value graph is a V. It is straight lines. 3, negative 1. 2, 1, 4, 1. 1, 3, 5, 3. And there's my graph. Alright, so this is the problem I added to the review. Okay. The vertex. What makes the absolute value equal to 0? 2. What's the vertical shift out wide here? 3. It's a negative A term, so there's a reflection over the x-axis. The shift is going to be right 2, up 3, and vertical shrink of a negative 1/3. Or you could say vertical shrink of 1/3 and then reflect it over the x-axis. It's up to you whether you write it out in that fashion or you just write the negative 1/3. And it has obviously vertical shrink. When I do my XY chart, I'm going to put it over here because I don't think that'll affect my graph too much. 2, 3. I'm counting down by 3s. I'm counting up and down by the denominators. 5 and 8. Okay. Let's start with 5. Negative 1/3, absolute value of 5 minus 2 plus 3. The absolute value of 5 minus 2 is the absolute value of 3. The absolute value of 3 is 3. Negative 1/3 times 3 is negative 1 plus 3, and therefore my y is 2. So when I put this in the chart, 5, 2, negative 1, 2. Y equals negative 1/3. Now we're going to go 8. 8 minus 2 plus 3. Negative 1/3, the absolute value of 6 plus 3. Negative 1/3, the absolute value of 6 is 6. Negative 1/3 times 6. Oops. Go right to that multiplication now. Negative 1/3 times 6 is a negative 2. So therefore my y is a negative 2 plus 3, my y is a 1. Make sure you don't make careless mistakes. And now I'm literally graphing those points. My vertex of 2, 3. And then I got negative 1, 2, 5, 2. I got negative 4, 1, 8, 1. And this is what my graph looks like. So writing the equation is this. It's working off the general equation. Now, we need to know HK is the vertex. In this graph right here, the vertex is clearly negative 2, 3. So right away, y equals ax minus a negative 2, uses the negative 2 there, plus 3. And right away, I should be able to get, when you subtract the negative, it becomes a positive. That's why you switch the sign for your vertex point. That's essentially the reason you switch the sign for the x, but not for the y. Okay, when you come up with your vertex. Now, you can do this one of two ways. All right? The slope of these lines is 1/3. That's your A. I don't love it because these lines that form the V have different slopes. One is 1/3 and one is negative 1/3. since both these lines have to have the same number slope, the sign will be different. Since it opens downward, what is the slope going to be? Positive, or what is the A term going to be, I should say? Positive or negative? Yes, Yassine? Negative. Very good. So the A term here, because of the slope, would be negative 1/3. And I can plug my negative 1/3 in, and this would be my answer. Now, the other way to do it is a little longer, but I do like it a little bit better, is to pick a point on the graph. That's not the vertex. I'm going to pick point 1, 2. And if I plug 2 in for y and 1 in for x, and I solve for my a, so I put my vertex in and I put my point in for x and y. 2 equals a times the absolute value of 3 plus 3. The absolute value of 3 is 3. We subtract 3 on both sides and we get negative 1. And we divide 3 on both sides. My a is a negative 1/3. And there's my a term as well. You can get it that way as well.